Okay, welcome back. So now we're going to talk about some other convergence tests. Okay, so let me get my prep notes here. So the first thing we're going to look at is what's called alternating series tests. So now we've all been dealing, a lot of the stuff we've been doing has been only series with positive terms, but we may also have alternating series. Okay, so in this case we have sum n goes from 1 to infinity of a sub n equals sum n goes from 1 to infinity. We're going to write this as -1 to the n minus 1, or n plus 1, it doesn't matter, b sub n. Okay, now, if, a couple of things, b sub n plus 1 is less than or equal to b sub n, so here the b sub n themselves are positive, but they are alternating. Okay, so like the whole term, it might be negative, but this is like the magnitude. Okay, so if they're decreasing, and if the limit as n goes to infinity of b sub n equals 0, then the series converges. Okay, now furthermore, we can actually find sort of an error bound. Okay, so if we let R capital N equal the total sum let's write it with a sub n, minus the sum up to n of a sub n. Okay, then the error here is going to be less than or equal to bn plus 1. Okay, so let's do a quick example. Now, this next one, I don't like it so much, but it's the best one I could think of, or the best one I could find. We're going to approximate to within a certain range. So, our first example. Approximate the sum from 1 to infinity of -1 to the n over 3 to the n factorial to 4 decimal places. Okay. Now, these are tenths. These are hundredths. These are thousands. This is 10 thousandths. So when we're doing it to 4 decimal places, we're finding to 10 thousandths. Or to accuracy, 1 over 10,000. Okay, so let's take our b sub n here. Our b sub n is 1 over 3 to the n factorial. Okay, let's first make sure it converges. I mean, it does. It pretty clearly does if you're, at least to me, it clearly does. But I can understand if you don't see that it does. So let's just make sure that it satisfies these two conditions. Okay? First, b sub n plus 1 would equal, let me move this around, 1 over 3 to the n plus 1, n plus 1 factorial. Now we have dealt a little bit with factorials. Remember, factorial means you multiply every number up to that one, right? So I'm going to factor out a 1/3 and an n plus 1 times, what am I left with? 3 to the n factorial. So for n increasing, this thing is definitely less than 1, so this is less than b sub n. Okay, so our terms are decreasing. Second, lim as n goes to infinity, b sub n pretty clearly goes to 0. Okay, this just becomes bigger and bigger. So now let's estimate the 4 decimal places. Now we're going to have to calculate some of these anyway, so let's just look at b sub 1, b sub 2, b sub 3, b sub 4 until we get to the certain point. Okay? b sub 1. Well, b sub 1, okay, that's going to be 1 over 3. That's it, 1/3. Okay? b sub 2. Move this over here a little bit. b sub 2. So I'm going to plug in 2 for here. So it's going to be 1 over 9 times 2, 1 over 18. Okay. Let's go over here. b sub 3. b sub 3, 1 over 3 to the third is 27 times 3 factorial is 6. Okay, and this becomes 1 over 486. Starting to see that, oh wow, we're starting to add up smaller and smaller pieces. Okay. b sub 4, 1 over 3 to the 4th times 4 factorial. 4 factorial is 24. 3 to the 4th is 81. So this becomes 1 over 1,944. Okay. We still are not quite at our accuracy, but watch what happens. b sub 5. b sub 5 is 1 over 3 to the 5th. Let me write that a little better. Times 5 factorial. And that becomes 1 over 29,160. So now we're within our level of tolerance. Okay, so we're going to just take, it's actually going to be, the sum is going to be approximately b sub 1 gets a -1. And then they alternate. And whatever that number is, which I wasn't in the mood to calculate when I did this. All right? All right. See you in the next video.